Welcome back to Chapter 7, Section 2. This is Part 2, more graphing. So yes, more attention to detail. We're going to get more into horizontal asymptotes and vertical asymptotes and how things translate. All the basic rules from the previous video apply. This is just more practice, and there's extra layers of complexity. I'll share my notepad with you, my notebook with you, and we'll get started. We're going to be on page 367. We are going to do numbers 2, 3, and 4. Okay? So let's start out with number 2. Y equals 3 over x take away 2. All right, so we already did something like this in in video 1. But now we're taking away 2 from all of it. I would love for you to think back to when we've graphed before, when we translated functions. What happened when we put a minus 2 in the back of an equation? It went down 2. So let's take a look to see what happens. Math makes sense, so it has to work out. Let's make our T-chart. Excuse me, get my trusty purple pen. Okay, 7 things, 6 points. So let's start. What's the first question we have to ask ourselves? We need to ask ourselves, what can't we plug in for x? What number is not allowed to go in this denominator? Well, the fraction is just 3 over x, and if we do 3 over 0, once again, we're going to get an undefined function. So when we plug in 0 for x, it does not exist, and that'll be our vertical asymptote. So let's pick 3 numbers that are bigger than 0, 3 numbers that are smaller than 0. If you want, you can use a scientific calculator or a graphing calculator, but not the graphing function, because I need you to learn what these functions look like before you can stare at them and analyze them to figure out the mixed numbers. I am going to use mixed numbers because it's easier to graph that way. You know that normally we only do math with fractions and improper fractions, but in this case, mixed numbers are okay. All right, so I plug in 1. 3 over 1 is 3. 3 take away 2 is 1. I plug in 2. 3 over 2 is 1.5. And if I take away 2 from 1.5, I get negative 1/2. If I have $1.50 and you demand $2, I owe you 50 cents, right? And if I plug in 3, 3 over 3 is 1, and 1 take away 2 is negative 1. All right, let's go up here. 3 over negative 1 is negative 3. Negative 3 take away 2 is negative 5. 3 over negative 2 is negative 1.5. Right? 2 goes into 3, 1 with 1 left over, negative, take away 2. So negative 1.5 take away 2 is negative 1 take away 2, that's negative 3.5. They're both negative, so we can add them together. $1.50 and $2 is $3.50, but they're both negative, so we put a negative in front. And then finally, 3 over negative 3 is negative 1. Negative 1 take away 2 is negative 3. All right. Feel free to pause, rewind, pause while I do the math for the 2 fractions when we plug in negative 2 or 2. Please, feel free. Okay, now, again, we can start being clever with our graphs. We might not be able to be clever. It's okay. I'm going to try to give myself some space. Oh, I know I'm going to go down to negative 5, but I'm only going up to 1. And I'm counting by halves, so how about this? There's 1. I'm only trying to be clever because, well, I kind of screwed up already, but you know what? No one's perfect. I'm trying to be clever because you got to watch it, and I got to make sure it's nice and spaced for you. I'm obviously going to do some bad stuff over here. I'm going to count by halves again over here, so that means every 2 boxes is an integer on the x-axis, just like in the previous video. Just seems to work out that way. I like how it looks. And and what did I say? We're counting by halves here. So -1, -2. Okay, so the x and the y-axis are going to be evenly spaced, and I do have enough room for -5, which is great, and a little bit extra. Okay, we start out with -3, -3. -2, -3 and a half, right? So -3 and a half, -1, -5. 0 does not exist, so that is where I have my dashed line. And at the bottom of it, I write x equals 0. 1, 1, 2, -1/2. Wow, that actually is crossing the x-axis here, which that was a no-no in the previous two problems. So I wonder what's going on there. And then 3, -1. All right, I know my vertical asymptote, and I'm ready to connect my dots, make my beautiful swooshes. But where is my horizontal asymptote? Unless I did the math wrong, which I'm pretty sure I didn't because this looks consistent, it's going to cross the x-axis, so it can't be here. Well, where do you think it is, right? What did we say when we started this? What does this -2 do? It takes the whole thing and then it moves it down 2, just like it did when we were talking about parabolas, or we were talking about polynomial functions, exponential functions, logarithmic functions. It moves it down 2. So let us take our x-axis, which used to be our horizontal asymptote, and let's move it down to -2. So when we're given something in this form, by the way, you must label it y equals, right? It goes through the y-axis, even though it's horizontal. I know it's kind of like, it's called bifurcation. Y equals -2. And where do we get that -2 from? Right here. So it's really nice when it's written in this format. We know our horizontal asymptote. We know our vertical asymptote. So now we can make our curves look good. We know that it's going to go up to infinity and never touch, never crossing the y-axis. It's going down, sorry, not down. It's going over to infinity. It's going closer and closer to y equals -2, never touching, never crossing. Likewise, as x goes to -infinity, it's getting close to y equals -2, never crossing, never touching. As we get closer to 0 on the x-axis from the left, it goes down to -infinity, never crossing, never touching, x equals 0. And here we have it. We took our basic rational function and we moved it down 2. All right, so let's see what number 3 looks like. Keep in mind, pause here if you need to copy anything down. I'm moving on to number 3. And when you unpause, guess what happens? You're moving on to number 3 with me. Crazy how technology works. Okay, I'll stop it. Y equals, we didn't state the domain and the range. I apologize. I always overlook that stuff because if you know me well, you know that I'm bad at listening to directions. We need to state the domain and the range. Domain, what are the x's? Domain. So remember in Algebra 2, we start with curly brace. The variable is x, such that, remember the big straight line is such that. So wait, look, x can be almost anything we want it to be. X can be any number you can think of. You can plug everything in there except what one number can you not plug in? You can't plug in 0. So the domain can be any x's such that x does not equal 0. Some people say all real numbers except 0, but this is the actually the Algebra 2 way of writing it out. Curly brace, x, because we're talking about x's when we talk about domain, such that, that's what the large vertical line means, x doesn't equal 0, curly brace. What about our range? What is the 1, so curly brace, yeah, I don't do perfect curly braces, I'm human too. Y, because our variable for range is y, such that, again, so wait, I get all these y's, right? All these y's. If I lined you all up, if I took my entire class and had half the class stand on this line, half the class stand on this line, and said, real quick, everybody, run to the y-axis. So everybody over here ran straight to the y-axis, right? Everyone over here ran straight to the y-axis. What's the one number that's going to have no one standing on it? -2, because no one's standing left or right of -2. So your range would be all the y's such that y can't equal -2. Where are these numbers? Your domain, x can't equal the vertical asymptote. Your range, y can't equal the horizontal asymptote. Where else did you write these numbers? Oh, look, you wrote x equals 0 here. You write x doesn't equal 0 here. You write y equals -2 here. You write y can't equal -2 here. There's your domain and range. Okay, good thing I remember that before we got too far. Hopefully I remember it for number 3. It's really fun talking about domains and range. All right, we start out with the same question. What is the one number we can't plug in to x right here? Is it 0? If I plug in 0 down here, I get 0 plus 4. 0 plus 4 is 4. I can have 4 in the denominator. But what if I plug in -4? If I plug in -4 for x, -4 plus 4 is 0. So I have y equals -1 over 0, and that cannot exist. So what is my middle number? -4. All right, so when our denominator, this is a big denominator, I apologize for my sloppy handwriting, check the book. You know me, always look at the book when I'm writing. When our denominator is not just an x, what do we need to do? Easy, we could just change the sign. That'll sometimes work, okay? Think back in the Wayback Machine to a lot of other tricks we've had to solve for x, but you need to always think, what number, when I plug it in for x, will make the whole denominator 0? -4 plus 4 is 0. That makes the whole denominator 0. Okay, I need 3 numbers that are bigger than -4, 3 numbers that are smaller than -4. And you know me, I'm very simple. -3, -2, -1. -5, -6, -7. Not very creative. All right. So let's start with, let's start with -3. We always started here. So I have -1 over -3 plus 4 is 1. So that's -1. When I plug in -2, -1 over -2 plus 4 is 2. So that's -1/2. When I plug in -1, -1 over -1 plus 4 is 3. You can check this on a calculator. Be careful. If you're using the whole denominator, parentheses, I prefer you just try to do it in your head so that you don't make a mistake on the calculator. Okay, let's plug in -5. We get -1 over -5 plus 4 is -1, and a negative divided by negative is positive. Let's plug in -6. -1 over -6 plus 4 is -2, so that's +1/2. And let's plug in -7. -1 over -7 plus 4, that's -3. And that's a third, because a negative divided by negative is a positive, 1/3. Okay. All right, again, we make a graph. We try to be as neat as possible. We try to predict what we need. Okay, wait a second. I don't even have x equals 0 over here. So we always need a y-axis, but I'm going to try to make it far to the right because I'm going to have to go pretty far into the negatives. Let's see if I have enough space to space it out by 2's. -1, -2, -3, -4, -5, -6, -7. I mean, if you're okay with that, I'm going to do that just so that we kind of don't smush it together. I apologize. -1, -2, -3, -4, -5, -6. I'm going to extend that a little bit. -7. Okay, now what about my y-axis? I'm only going up to 1 and down to -1. So, and then again, I'm counting by fractions here. So let's do 1/4, 1/2, 3/4, 1. -1/4, -1/2, -3/4, -1. All right. Okay, I better use another color since I have purple close to my -7. So -1 comma a third. Well, here's a quarter, here's a half. So a third is in between. -6, comma a half, right on the crosshairs. -1, comma 1. -4, here's where we get nice and neat. -4 does not exist. There's our dashed line, arrow at the top, arrow at the bottom. X equals -4 down here. Always label it. I need you to label it because I need to know that you know. -3, -1, -2, -1/2, and -1, -1/3. All right. So what does it look like the horizontal asymptote is going to be here, right? The previous problem we had, it crossed the x-axis, but this kind of looks symmetrical around the x-axis, right? 1, -1, 1/2, -1/2, 1/3, -1/3. Well, wait, let's just be sure, right? Because now I'm confused. There's way too much math, very complex. Is there anything written out here? Is there a +2, -2, +5, -5, plus anything, minus anything out back behind the fraction? Just like we had in the previous problem, number 2. There's a -2 out back. No, right? It's just a +0. There's nothing there. So what is our horizontal asymptote going to be? It's going to be y equals 0. It's going to be the x-axis again. So this is our horizontal asymptote. Y equals 0. Okay, we're going to label it, right? It's going to help us with our domain and our range, right? We're just helping ourselves too. All right, so I'm going to graph it so that I know Mr. Mitchell knows that it's not going to cross or touch. X equals -4. It's not going to cross or touch. Y equals 0. Same over here. Okay, oops, not perfect. Oh well, human. Okay, let's talk about the domain and the range. What is the one x that I could not use for my rational function? Curly brace, my domain are all the x's that I want, such that I don't choose x does not equal, boom, boom, -4, curly brace. Ugh, ugly curly brace, curly brace. Range. What is the one y that doesn't have any partner, right? Again, if I lined my whole half my class up on this curve, half my class up on this curve, and I said, all of you run straight to the y-axis. That's over here, by the way. So everyone over here ran straight to the y-axis, right? If you were standing here, you ran over to 1/2. If you were standing here, you ran over to 1, right? Everyone runs over. Everyone runs over. What's the one y value that doesn't have anybody standing on it? 0, curly brace, okay? And here's our domain and range. All right, one more. I know the video is getting long, but the more we graph by hand, the better we understand the nature of these functions and the deeper we can go when we're in class. So let's do number 4 together, and that'll be it for this video before another video about even more graphing. Y equals 1/x-1 plus 5. Okay, I want you to start thinking. Where did this move? Up or down, how much? And actually, if you want to, left or right, how much? If you're not there yet, it's okay. All right, we always start with the same first question. What is the one number that I can't plug in to x? Because when I plug it into x, the denominator becomes 0. If you said 1, very good. 1 minus 1 is 0. 1/0 doesn't exist, and therefore it doesn't exist. Can you start thinking about which asymptote it is? Can you start thinking about how that plays into the domain? And again, if not, it's okay. Let's follow the steps. 3 numbers bigger than 1, 2, 3, 4. 3 numbers smaller than 1, 0, -1, and -2. All right, let's be careful with our math. Let's plug in 2. 2 minus 1 is 1. 1/1 is 1. Plus 5. Ooh, I was almost not careful. 6. Let's plug in 3. 3 minus 1 is 2. 1 over 2 is 1 over 2. Plus 5. I said mixed numbers are okay. 5.5, right? It's easy to graph a mixed number. 5.5 is easy to graph. 11 over 2, not so easy to graph. 4. 4 minus 1 is 3. 1 over 3 is 3. 1/3 plus 5. Again, I said mixed numbers are okay. 5 1/3. Let's plug in 0. 0 minus 1 is -1. 1 over -1, -1 plus 5. It's 4. Let's plug in -1. -1 take away 1 is -2. 1 over -2 is -1/2 plus 5. All right, I'm down a half. And then I win $5. I'm down 50 cents. I win $5. Overall, $4.50, 4.5, right? -1 plus 5. 5 take away a half, 4.5. Let's plug in -2. -2 take away 1 is -3, and 1 over -3 is -1/3. All right, how good are you with fractions? -1/3 plus 5, or 5 take away 1/3. 4 2/3. Use a calculator to check. Okay, alrighty. Now let's try to be smart about our graphing. Do I have any negative numbers on the points that I chose? No. In fact, the smallest value for y is 4. So, I guess I don't really need a negative axis over here for my y's. So my x's can go here, but I want to go up to 6. I actually better be really smart about this. So let me just draw it like this. Let's say this is 6, 5, 4. I think I can start with that. 6, 5, 4, 3, 2, 1. And then here's my x-axis. I could do -1, -2. That'll work. -1, -2, 0, 1, 2, 3, 4. All right, a little tricky to be smart about it. Just takes a lot of practice. If you do a standard x, y, 10, -10, you're good. Okay. -2, 4 2/3. Well, if this is 4.5, then 4 2/3 is going to be a little bit above it. -1 is directly at 4.5, and 0 is on 4. When I have x is 1, I have my vertical asymptote, dashed line, x equals 1. Always label. 2 is at 6. 3 is at 5 1/2. 4 is at 5 1/3, so a little bit under a half. Okay, so this is, I don't know, I'm a little scared. But wait, what is my horizontal asymptote? 5. So we go up to y equals 5. We draw our horizontal asymptote, we label it, and now we can fill in our curve. We are not touching, we are not crossing. We are not touching, we are not crossing. No touching, no crossing. No touching, no crossing. Okay. Now, you know where to find the domain, right? We can talk about all x's such that x does not equal 1. We can use all y's, or we're going to get all y's, depending on how you want to say it, such that y does not equal 5. Okay? So, graph the function, state the domain and the range. All right? Good job, everybody. Practice, practice, practice. I know it's tedious. I know that there's a lot of parts. I know that you're going to make mistakes. That's okay. The more you do, the better you're going to get. All right, so stay tuned for the next video.